we finished up we finished up down here. We finished up correlation and regression, right? For bivariate data, which basically means two variables, X and Y values, right? This is what we did for the past couple of classes. So we finished up the last part. Now we're going on to the more challenging part, right? That is sample distributions and estimations, right? So we're going to take a look at a distribution that's full of samples, right? And we're going to look at finding E of X and variance of X, finding confidence intervals and point. So we basically, here's technically what we're doing. We have a large population and we're trying to get data on the population or statistics on the population, like mean. But the problem is we're not ideally going to work with the mean because there's a large amount of values population. So we're going to take a sample and try to use that sample, right, to get the mean that will give us an estimate for the population. So we're kind of focusing on the sampling, right? You all should remember the different sampling techniques that we had in module 1. We learned about systematic sampling, stratified sampling, simple random, cluster sampling, quota sampling, right? So we looked at all those different types of sampling. Now that we have the sample, we're going to learn to use to analyze it. We're going to learn to analyze the data now, right? We're going to learn to analyze the data. Okay, so we're going to get a sample distributions of mean and proportion. I'm going to explain what those things mean. We're going to learn about something called the central limit theorem. It's a theorem that allows us to approximate and how to get unbiased estimate. All right. So let's jump right into it. Right, I'll use this whiteboard here. Right, I'll use this whiteboard here to explain. But it just kind of complicated, so at any point you get confused, stop, all right? That's okay? That Darian listening? Darian listening, right? Ravisha, you listening? So I can tell Jaden listening, Ravisha close by. Darian, are you there? Elaine, do write on board, please. I am going to write on the board. Take it off, please kill it. Elaine, take off the mark now. Okay, nice. So what is here? Let's say I gave you a big population, right? Let's say, hold on, let's try and think of some symbols here. Okay, I can't get symbol, right? Let's say I gave you a big population. So that rectangle population. Of course, we know it's very difficult to work with the entire population. So what I'm going to do is take a sample. I use a sampling technique and I find a sample. Okay? And then within that sample, I find the mean. That's my first sample and my first mean. Right? And I'm going to do it again. And again. And again. Right? So this will be my next mean based on that sample. And then I have a next mean based on that sample. And I do it a lot of times, right? So I'll do it n times. So the last one will be x by n. Right? So now what I have formed here is a distribution of sample mean. This is now a distribution because I have a whole set of samples that I took the mean from. Right? So what I have here is called a distribution of sample means, right? And then what we formally call this? We formally call this the sampling distribution of means. You understand what distribution of sample means mean? Have a distribution, a whole set of values, but these values are means. So we call it the distribution of sample means. Or sometimes they call it the sampling distribution of means. Is that okay with that? Kaden, are you okay with that? I need you all to respond. As I said, this is a little bit tricky, right? Yeah, it have things for applied, she set it up, right? So you'll get it. She has to add it in. Right. So now that we understand what it means to have a distribution of sample means, now we can find a few things, right? So watch this here. Suppose I wanted to get the expectation, right? I want to get E of X bar. That's the expectation of mean. Because remember, I have a whole set of means, right? So I want to get the mean of the sample distribution of means. That is called EX bar, right? So listen again. This is the mean, right? That is the mean of the distribution of sample mean. So as I said, sometimes I'll call it, some books might call it the sampling distribution of means. So every time you're working with means, this is the distribution you're using, X bar. You're no longer using like just random values from this sample, right? You're using the means of this sample. And to find X bar, we can do a little calculation and it will recognize that E of X bar is the same as mu, right? E of X bar is the same as mu, right? Mu is what we call the population mean. So that worked out to be really, really nice, right? So X bar, E of X bar is mu, right? So make a note that mu is your population mean, right? So X bar is the same as mu. But if I ask you to find variance, I write it on the opposite side. Variance of X bar is a little bit different. Variance of X bar is equal to the population variance, which is sigma squared, all over n. Right? So mean and variance of this new distribution is mu and sigma squared on n. Right? So as I said, this is the mean of this new distribution. The mean is mu and the variance is sigma squared on n. Right? And again, this only holds for this new distribution called the distribution of sample means. Okay? So anytime you see distribution of sample means, that is what you use. Please remember that mu is the mean of population. Sigma squared is a variance of population. Right, so technically what's different really is the variance. The variance is no longer sigma squared alone. With this distribution, we call it sigma squared only. Right? So Well, why do we need to know this? Why do we need to know this? Well, here's what. Let us see our original data, right? Let's say all the values in there, Let's say all the values in there follow the normal distribution. Right? So, hold on, eh? Right. If population of the original values was normal. Right? Then what will the distribution of X bar be now? So remember, here's the problem earlier. We have a population of values. We have all these values, right? And the values follow a mean distribution, follow a normal distribution. We need to figure out now, okay, if I go and I find all these X bars, right? What distribution will these X bars follow, right? The good thing is that we know that the mean of X bar is the same mu and the variance is still sigma squared on n, right? So watch how nice that little thing that we learned earlier going to help us out now, right? All right, and it's in a different color now, right? So remember I said that the original values were normal. Hopefully you'll remember this, that X follows a normal distribution with mean, mu, and variance sigma squared. Now, for this new distribution that we create, right, X bar will follow a normal distribution of mu, right? Remember the mean is the same, but the variance is now sigma squared on n. Right? So remember, you all might ask, okay, well, why we doing all this? Why we just can't leave it as use the original value? The problem is if we use the original population, we had to work with all those values. So the simpler thing to do is to take samples, and from those samples, just have the means. So it's easier to work with a distribution of sample means than the original distribution. So that's why we have to theoretically now be able to describe what the distribution of means will look like. So if it were normal, it will still be normal, but the variance is sigma squared on n. Okay? You're okay with that? Everybody? That's the most important thing. Let me know yes or no, please. Just message yes or no in the group, please. Amber, you okay with us? Bradley, man, you're not paying attention, man. No messaging, Bradley. Bradley. I don't call you, man.
What happened, sir?
You follow what's going on?
Yeah.
You sure?
Mm-hmm.
All right. All right. So, do you all remember how to read the normal table? So, let's just use one example of this. Let's just use one example of why it is we need to know the distribution of means, right? Right? Just think about this. Think about it. Suppose I said, well, Jesse, find the probability of X is more than 20. That's easy to find, right? Because X will come from here. But suppose I said, Jesse, find the probability of X bar is more than 20. Then we cannot use the original distribution. we have to have a new distribution for X bar. So now we're going to use this when we standardize it and thing. All right. So everything that you're going to see for those who did hypothesis testing and thing already, right? And those who did confidence interval, you'll recognize that we always estimating the mean, or we always doing a hypothesis test for the mean. So it means that we need a distribution for the means. All right. So it's important that you'll understand why it is we're doing this, right? All right. So let's come with a little example here. Right, you all need to get tables. I think in the group has the normal distribution table, right? And I want to see what honestly everybody send my answer. All right. So I'll call on the question, but don't write everything. You just need the important stuff, right? Right, in a class of students, the male and the male students following normal distribution. Right? They follow a normal distribution. They have a mean, sorry, right, let's here for you, right? They have a mean of 70 kilograms and a variance of 25, right? So I'll write it here one time. So they have a mean of 70 kilograms and a variance of 25. Remember, you don't write, you write standard deviation squared, right? So I'll write it here one time. Nice. So let's say we chose, so we're choosing four male students. Right? Hold on, let's write that kind of four male students chosen. So we're choosing 4 males, right? 4 male students chosen. I would like you to find the probability that their mean, look at how I'm writing it, X bar, right? Look how I'm writing it there, right? X bar, right? Let's see if we can find the probability that their mean is less than 65 kilograms. All right? So how are we doing this? First thing, you would have to recognize that we have to find X bar, probability of X bar. So the first thing I will write here, right? Let me change color again. The first thing I will write here is that X bar follows a normal distribution of mean 70 and a change in the variance one time, 5 squared over n. N is how much here? What's n here?
4.
N is?
4.
Wait, somebody using the mic. Yeah, use the mic. N is how much? Amber, thank you, Amber. But if you follow Amber, you use the mic, please. So it's 4. Okay? If you want, then you can leave it like that. You can leave it as 5 squared on 4, right? Or you can actually work out the value and you can write like you can write X bar follows a normal 70 divided by what's 5 squared divided by 4? What's 5 squared divided by 4? 6.25. Thanks, Jesse. Right, you know the sign say thank Bradley as you said, Bradley and Selma, everything else. Right. So what do we need to find? We need to find the probability of X bar is less than 65. So, Mr. Bradley, what's the first thing we have to do, Mr. Bradley? Mr. Bradley, what's the first thing we gotta do?
The first thing we gotta do is yeah, it's not a deviation, we need variance. Easy formula.
What we gotta do?
a formula.
Right, but remember we're going, it's a normal, right? Can we read up X bar from the table?
Yeah.
No, remember we can only read up Z bars from the table.
Oh, I understand. Okay, I know what it means.
So the first thing is what? What do you call that?
The first thing is you said Z bar.
It's called what? Standardization, right?
Yes, sir.
Right, so you have to standardize it, right? So when you standardize it, it will be 65. Hold on, I'm pen now working. I'm trying to fix my pen. See then. What you do again is standardize.
B again?
No, Jaden, I'll come back to you in a little while. I'm gonna cycle around the class, right? I want to reach your show. Jaden, what you do again? $65 minus what? Right. So can we write it nice now? So X minus, right? Remember it's X minus mu all over sigma. Right, so X minus 70 all over, right, Collier, here's where you have to remember that the value we're using is the square root of 6.25. Okay? So here's where the whole question, the dynamic of the question will change. If you all make a mistake and use 5 down there, you will get it wrong, right? It's the square root of the new variance, 6.25. How much is that? P is D is less than what? How much is that? Carry on.
Is
What you get? Minus what? Minus 2. Alright. So now we do our favor now to rotate table. Right, rotate table and find the probability of less than. Right, please remember you can't find a negative number, right? So I hope you all remember this. -2 less than is quite here, right? So that is the same as 1 minus 5 or 2. So go take calculator, sorry, go take a table. Already calculated, do it for you as well. Go take a table and get the value for 5, 2 and minus it from 1 10 away again. Wait, no, 10 over 5 2 goes. Multiply from the table, 0.977. And when you minus, you get 0.022. Good job. Good job, Keelan. Can we show you work out that? Can we show? But we should some mother fair and number fair mother. I'm still doing anything.
Yeah, you can yeah, the table. So but you can send the tables on the group. I don't have it on my right now.
Check in the group.
Which file is it?
As you were looking number.
Right.
Somebody can just send it back for him there in case you say that. Although I think we sent it recently, yeah.
Yes, I just don't have the one I just use on my right now.
Anybody can just send it back in the group there. Okay, let's send it back in the group now, please. Yes.
Yes, sir.
All right, nice. Let's try next one now. Right, again, I'm not interested in I am not taking to write down the whole question, just listen to the important things and write it down. Okay? Only the important things are what to write down, right? Right, and then you'll message your answer. Darian, excuse, are you there? Darian Sinclair, are you there? Darian. All right, how to remove Darian from this class? Why not even responding? Yeah, I have Darian mother number there. All right, try this, please. Again, do write everything down. So could I message the admin to get added for the applied LMS? Yeah. Message John, tell her to add you to the applied LMS. I think she fixed it up again today. I do have these new videos, right? I have older videos, right? But those videos were shorter. They were from Crash Course, right? So you can always go back and look at these. Right, sorry. Right, try this here. The volume of wine bottles. The volume of wine in bottles are normally distributed. Again, don't write everything. Normally distributed with a mean 758. With a mean of 758. And a standard deviation of 12. And a standard deviation of 12. A random sample of 10 bottles is taken. A random sample of 10 bottles is taken. And the mean volume found. And the mean volume found. Right, sample of 10, right? Calculate the probability that the sample mean. Calculate the probability that the sample mean is less than 750. Calculate the probability that the sample mean is less than 750.
They can just go through that thing again.
No, boy, no.
No, so I just missed out one piece. I just missed out one piece.
What do you call it?
I think it's just the first piece I missed out there.
So the mean is 758.
Yeah.
And the deviation is 12.
So is the probability that x bar is less than 7, right?
Huh?
Is the probability that X bar is less than 7, right?
750.
Okay.
Look at it there for you. Work out that. I just gonna call that young mother and tell her she not paying attention for. Let's give her 1 second. Work out this in the meantime. Good method answer. I give everybody enough time there. Method answers there. Let me see what we got. So far, we have 3 answers. 2 answers, sorry. Kaylin, Jesse, Eki. Ooh, the group B shots and an answer. Any answers there? I get something from Bradley, all of you? Let me see if you get a little Bradley.
Wait, just 1 second. Just wait. 1 sec. 1 sec. I have it right here. I have it right here.
Amber didn't get yours too. Oh Lord, what is that, Daria? What's the probability? Are we so small? So big, I can't tell you, look at it. So the first thing you should have is this, right? Write the new distribution. Right? X bar follows a normal distribution with mean 758 and variance 12 squared is 144 divided by 10 is 14.4. Now they want us to find the probability of X bar is less than 750. Right? So the first thing I'm gonna do is standardize it. So that'll be Z is less than 750 minus 758 over the square root of 14.4. Right? I got the probability of Z is less than minus 2.108 or so. So that'll be 1 minus. That'll be 1 minus 5 of 2.108. Y'all got those same values? Yeah. Right? And what are equal to 0.1? Should be a small value. I see most people getting 0.0174. It's according to how you kind of round it up. But I saw most people have 0.0174. You just, yeah, that's okay. If you just use 2.1, that could happen, but minus 2.1, that could happen, right? But whenever you're doing this, remember from the table, you could get 3 or 4 decimal places, so don't round off too much, right? All right, nice. So that's how you handle it if it came from a normal distribution. Anybody could tell me. Suppose it was a binomial distribution, NMP. Small binomial distribution. Real small, right? It's not big. You only remember. Right, forget this second question. But suppose it was a binomial. Suppose it came from a binomial, real small, NMP. Anybody can tell me what X bar will be? Think about it first. What do y'all think? What distribution X bar will belong to? Anybody can guess? Or you can ask ChatGPT and tell me anything you want. What do you all think X bar will be?
So,
Yeah,
you, I don't understand what X bar would be.
no, I didn't say it. I was looking for a guess. If X was binomial
Yeah.
and N was real small, what do you think X bar will be?
Um, like,
Well, the
well,
simple answer is it might be binomial as well. Right? It might be binomial as well. But does it make sense if N is very small, 6 values, 10 values? Does it make sense having a sample distribution of means? That's it, right thing. Right, don't make sense, right? Because you could actually just use all the values and find the mean and population. But suppose it binomial and N real big, like 200 values. What shall you do? We did this in module 2. What do you do when N is very large for a binomial? It looks like what? It looks like what?
so quick question.
Huh?
Quick question. If N really small, which don't make sense, and like it'll get more of error, or like yeah, is more of a chance of an error or something.
No, you see, if N real small, right? If the whole population only have 10 values, it don't make no
Yeah.
sense doing sampling. It makes sense.
No, but like you're saying in this case where we using an N value which is small, that means when we do the calculations, we
Right,
wouldn't
no.
like get precise.
Yeah, it wouldn't make sense. It don't make no sense doing a binomial. We just, as you say, we're introducing unnecessary errors. So we just use the actual values and find the mean. Right? But my new question is when N is very large, let's say 200 or 500, what do? We did this in module 2. Right, very good. Jesse said we're gonna switch it to normal. Right? Jalen said the same thing. So we're going to apply, well, we're not doing continuity correction again, right? But what we're going to do is we're going to use something called central limit theorem, right? And that central limit theorem allows us to see, well, here's what. This is a very big binomial distribution. So let's convert this distribution to a normal. Okay? So head up central limit theorem. Let me give you a little notes. That's a little note on it, right? Always remember, most distributions, when they get too big or they have too much values, they just look like a normal. So you can always approximate it to a normal. All right. So for samples taken from a non-normal or samples taken, we do not write in a Darian, pen, paper. Remember them things? Pen, paper, write, listen to Sue. I don't know if you remember them kind of things. For samples taken from a non-normal distribution, right? From a non-normal, oh sorry, do use distribution, use population, sorry. From a non-normal, non-N-O-N dash normal, from a non-normal population with a mean mu, and variance sigma squared, with a mean mu and variance sigma squared, by the central limit theorem, so sometimes you will see in book CLT, that means central limit theorem. By the central limit theorem, X bar approximates to what just happened there? Hold on. Right, I just moved up my screen. You'll see now a blank screen now, a blank whiteboard. X bar approximates to normal with mean mu and variance sigma squared on n. You'll see that? It's not happening on my screen. I can move it up. So wait, you have to keep moving it up, or it moves automatically? Oh, you all have to scroll down. Oh, shucks. Okay. I thought it happens automatically. Anyway, for samples taken from a non-normal population with mean mu and variance sigma squared, by the central limit theorem, X bar is approximately normal and X bar follows that normal distribution there. Right? Same thing we had before. It's just a theorem. We have to state the theorem before we use it. Provided that the sample size n, is large. Provided that the sample size n is large. Provided that the sample size n is large. N is more than or equal to 30, right? Okay. So whenever you see a question with something that's a little bit different, this is what we do. Right? Just as a quick reminder, because we only did the binomial, right? So as a quick reminder, if X follows a binomial, right? If X follows a binomial, right? Then your mean is n by p, and your variance is npq. Okay, make a note of that now, please. Okay. Alright, so again, everything here is for me, right? Let's try one now. Let's try one as cool enough, right? Right, so scrolling up. I think it says number 3 or something, right? I can't remember what number this is. But let's say X follows a binomial distribution with N 9 and P 0.5. Right, I would like you to find the probability of X bar is find the probability of X bar is more than 5. That the same process, same process. All you have to do for your next step is by central limit theorem and then write what X bar is. Right? Do you think? Right? Of course, you need to find mu first. I just gave you the formula, right? Find mu and then find sigma squared. Do that, please. If we can squeeze in one more, that'll be good. Try this, please, and do the usual message answers, right? Anybody lost? Right, so I just checking your values out, right? 9 by 0.5, that's 4.5. And for those who forgot, remember Q is 1 minus P, right? Right, so that's what about 9 on 4, 2.25. So therefore it will be 4.5 and 9 on 4. Right? You can write 2.25, it don't matter. Actually, I'll just leave 2.25. And now they want the probability. So remember, you have to write this up. You can't just jump from a binomial to a normal. Okay? So X bar is more than 5, so we have to standardize. That's 5 minus 4.5 all over the square root of 2.25. Right, tell me if you all got the same values, right? Right, I got 1, 2. So that'll be 1 minus 5 of 0.33. Right, oh wait, you know what I forgot to do? I forgot to, what did I forget to do? Show me the correction. I made a mistake. I'm now watching back there. Anybody can tell me what's the mistake I made?
So on the bottom part there, not is it more than, right? So it's not supposed to be 1 minus.
No, not that. I made a mistake higher.
Um
Use the sigma squared on n. Very good, Jesse. It's supposed to be sigma squared on n. So it's supposed to be 2.25 on n. N was what did I give you n as? Did I give you an n? Okay, I see what did I give an n value? No, n was that was the original distribution. Sorry. The sample that we took was large. So let's use n is 30. That's my fault there. So I now see I left out that. That's why I didn't write it. Sorry about that. N is 30. So that's 0. This value here is 0.075. So the square root of 0.075. Right, so I made a mistake. It should have been 1.826. I sorry about that. I didn't give it the n value. Remember, n can be 9, right? N has to be a value 30 or more, right? So in this question here, n was supposed to be 30. Fix it now, please, tell me what you got. That's the final answer. What's the value before that? So Kaylin have 0.0036. Nine six six four. Okay, anybody else got that? Yeah, point, okay, good. Yeah, that's it. Amber, you okay with this? Yeah, okay. Alright, so again, you got to look out for this, right? Once you see a question, say find anything with the mean, find the estimate for the mean or anything to do with the mean. Right? We need to be able to, we need to know that we're using the distribution of the means. Alright? Right, could we squeeze in one more by?
Nah.
Yeah, okay, I like that, Brad. If Darian had messaged an answer, we'd have stopped. Darian didn't message anything. So I had to hope and pray that he messaged something in. Last one. Remember in unit one, doing distributions, we know the normal and the binomial, right? Number three. Yeah, that is. Last one are we done? That's 50, right? 12 and 0.4. Right, last one, right? Everybody gets an answer, we done, right? Jiren, last one, Jiren. As a finished message your answer. Right, when you finish this message. And you are free to go. Wait, what is that? Give out different answers like Kaylin, Jesse. Kaylin, check back yours, right? So of course, you can find X bar. X bar follows, remember to see by central limit theorem. Right? X bar follows on normal. Right? I'll multiply it one time, 12 by 0.4. I got 4.8. And then you multiply that by 0.6. And then you have to divide it by 50. So I got 0.0576. Right? Now you want to find the probability of X bar is less than 5. So that's the probability of Z is less than 5 minus 4.8 all over 0.0576 is square root that. So that'll give you the probability of Z is less than. I got 0.8333. Which is equal to what? You got 2, anybody got 0.8333? Yeah. So based on what you all said is 0. Hey, look that way. 0.797 around there. Yeah, somewhere around there. Okay, so nice. So that's how we do this, right? So next, now that we learn this, we just have to learn, instead of finding mean, you have to learn to find proportion. Right? That's something that you might see. You might see the proportion of people do this. Just kind of like saying mean, very close. But instead of mean, we're going to find proportion. Right? And after this, we have SB. We're going to start our different forms of checking to see if the mean correct. The first one is to find the actual mean using our formula. The second one is to get an interval where the mean will lie, and the third is hypothesis testing. Those are the three things that we have. Technically, once we build on this properly, we can do all that in one session, but I'll take my time and do one each, right? So we have confidence interval, point estimates, and a hypothesis testing. All these testings are used to check to see if the mean is actually what it is, or to find a mean, where the mean lies. All right?